This talk is about using taxonomy for auto-categorization and some of the limits that it can reach and where you go when you reach those limits to get additional information. So I think I wanted to start by talking about really what the characteristics of taxonomies and thesauri. Most of them were really developed to support a human indexing process. So the structure of a thesaurus is the concept, the preferred term, or the pref label in Scots speak, and alternative language, non-preferred terms, and alt labels. But then you get things like scope notes that define the limits of use, and you get indexer notes guiding how it's indexed. These are written for human indexers to use, so they're useful, but they're only partially useful for a machine indexing process. And I just want to explore how we can leverage those kinds of taxonomies to generate machine indexing rules and where we go beyond that. So let's start with just what is a taxonomy for, or a control vocabulary, or a thesaurus. I always think the primary function of taxonomy, or all of those other things, is it's a bridge. We're building bridges between what information creators, authors, the writers of documents use, the language that they use, and information users, the people doing searching and browsing. And taxonomy is this bridge that, if it does its job, connects those two fundamentally different groups together. So that bridge needs a bit of clarification, a little bit of decomposing. On the left side, we've got the language that people use in search and browse experiences. And on the right side, we've got the language that's found inside documents. And this bridge that connects them, this taxonomy and classification schemes and so forth, is, for a human indexing process, all those things I described. It's the labels, the language, the definitional notes, the scope notes, etc. And a human being looks at the language of the taxonomy, looks at the language of the document, and they make judgments about how to classify that. But what's missing from any information system is all that latent stuff that's in the head of the classifier, the indexer. Just the native language skills that they have, and also domain knowledge. Now, when we go to create the categorization rules, the indexing rules, we're really trying to systematize and formalize all that latent knowledge that a human indexer would have in expressions that machines can process. That's the job that's being done, and that's the job that would end up in these yellow buckets in my diagram. So, if we look at the content of taxonomies, we've got the terminology, we've got synonyms, we've got things like the notes fields that are used in taxonomies, definitional notes and so forth. And we've got all the associative and hierarchical relations. And we've also got homographs. So wherever there's a homograph, let's think of classic one, Mercury. Mercury the planet, Mercury the metal, Mercury the Roman god. All of these homographs are the things that in a classification system you need to distinguish. When you find the word or phrase in the document, you need to know which one of those things is being talked about to go from a literal match to a conceptual or a semantic match. Now, what we can do is process the taxonomies to extract essentially three things, and there's different syntaxes for storing this, but essentially we're in the blue bucket on the slide, we have things that denote the concept. Strings you will find in the document, which if you find them could indicate that they are about that concept. the could, because words are very elastic. Dr. Peter Roget, the creator of Roget's Thesaurus, describes language as the elasticity of language, the stretchiness. Words are just not pinned down into a single meaning. So when the system encounters one of these words or phrases that could denote the concept, we need to contextually validate that. And what we look for is other language around that match. And there's going to be negative and positive validators that we will find in the surrounding language. And what we really do there is basically tot them all up. How many things are supporting evidence and how many things are negative or negating evidence that this denotation is actually about that concept. So we developed some algorithms to basically parse any standard thesaurus or any standard taxonomy, push the taxonomies in, push out machine indexing rules. And we've been experimenting with these with some of the commonly available taxonomies and thesauri, things like medical subject headings, mesh, NASA thesaurus, etc. So, and they generate a surprisingly rich set of rules, or they can generate a surprisingly rich set of rules. So when we process mesh, for instance, which is just under 30,000 concepts, it yields 1.2 million indexing rules through the mining process of exploring all of its semantic relations and building out of those semantic clouds of denoting, validating, negating evidence. So there are lots of different things that are covered under the word, the very elastic word of taxonomy and taxonomies. There are things that are just categorical schemes. So on the left there is IPTC, news codes used for classifying news. This is basically categorical language. I need to put my glasses on to see which one I picked here, but so yeah, we've got energy industry, right? So energy industry, yes, you will find that in the news, but you need to find an awful lot of other things that are instances or examples of energy industry that belong under that category. It's a very general and broad category. On the right, we have something from mesh, which is a much deeper, richer control vocabulary, and it is essentially it's a subject heading thesaurus. So it's very specific, goes down to deep levels, and the language that you will get out of that kind of taxonomy is likely to be found in the document in a way that a classification scheme isn't. Classification schemes are not going to help you with machine indexing rules unless we do something to help them out. Subject headings, definitely we can. So what is all this stuff? This stuff is essentially what I would generically classify as a reference base. The reference base is derived from the taxonomies. We're going to look at linked open data next. It can be derived from search logs, query logs, etc. And of course, it can be derived from the documents through doing classic text mining and clustering and looking at terminology that you would find in the corpus. So the taxonomist needs to reference all of that kind of material to come up with a taxonomy that works, that will do the job. But they're also feeding into human-machine learning activities, which I'm going to touch on at the very end of this talk. So if we have a look at the linked data side of things. Let's say you've got a taxonomy, which is at that broad bucket level. It's not a deep subject specific thesaurus. Then linked data can help us out in many domains, not all domains, of course, and not necessarily enterprise content as opposed to content that might be described by some of the scientific and engineering, life sciences type of linked open data sources. But there is a lot of linked data, and it's growing all the time. If I had a bumper sticker, this is a very nerdy thing to say, but if I had a bumper sticker, it might be I love owl same as, because simply by making assertions that something in one's taxonomy is the same as some things out there in the linked open data cloud means that we can mine and pull back all sorts of additional knowledge that can be processed into our rules base, essentially, for indexing and categorization. So I'll have a look at some examples of this. So we ran last year's KM World. We did a show and tell about where we brought in 1 million news articles. And the Associated Press very kindly lent us their full taxonomy set, their indexing taxonomies. So we did indexing of the 1 million articles against the AP taxonomy set, but we did something else. We connected the taxonomy nodes from Associated Press into the linked open data cloud, and it was incredible what happened when we did that. We were able to answer questions. Let me go back here. We're able to answer questions like, find me news articles about US tennis players born in Michigan after 1980. Now, the data is not in the taxonomy, and the data is not even in the content. But by connecting the taxonomy to linked open data, we have a massively expanded set of knowledge. Remember that slide I had back where it was, let me go here. Where is that slide? Yeah, this one, right? So the human indexer, we take for granted all of their knowledge, all of their linguistics and so forth, and their general knowledge, and we take that for granted. They're doing it without even thinking, and we need to give the machine that. Well, linked data is one of the ways to help populate in structured and machine intelligible, queryable ways the kind of content that the human being, as doing an indexing job, takes for granted. So I described, I'll skip through these slides fairly quickly, I think. So basically here is the Associated Press taxonomies. They link also out. They have a pointer to an equivalent in the linked data cloud, and then we pull back from that linked data cloud a ton of data, and that data is structured, it's machine processable, and it gives us a much richer set of information to do our indexing. So then when we get a natural language question, such as US tennis players born in Michigan after 1980, we can actually process that. So we use NLU, natural language understanding, of the query to process it, parse out the different bits of it. Well, the first thing that happens is an intent engine. So what is the intent of the search query? What type of query is it? Are they looking for a product? Are they looking for facts? Are they looking for this, that, and the other? That intent processing then helps guide the parameterization of that expression into things that we can direct into the graph of the linked data, so that we actually precisely target 1980 into the DBpedia property of birth date. So there's a predicate for that, and we can direct the parameter to that, and we can use it in the indexing. So I've only got a minute a minute left, so I'm just going to go very briefly here. So the other side of what the taxonomist needs to do is interact with the indexing that's happening, the auto-categorization, and this is essentially information that needs to go into the learning base, and that learning base can be fully human review. Is this a good or bad choice? Is this a good or bad choice? Or a machine learning, human learning process. But essentially what's happening is we are capturing yes and no, perhaps on a finer scale, but yes and no to conceptual matches, and that produces an additional input into the rules logic. So what happens when we do this is we grab sentences, we grab paragraphs right out of the documents, and we store them in the taxonomy management system, or an extension actually of the taxonomy management system. So we've got mined information from the literature, from the corpus, and if we say, well, you know, we've got N classifications of this concept, and some of them are right and some of them are wrong, we can remine all of those sentences and look for what were the patterns here, what were the things in common between the good and the bad indexing choices that were made. So, in summary, standard taxonomies and thesauri can be mined, any one of them can be processed to generate some machine indexing rules. And I forgot to mention, there are all sorts of things you need to do depending on the vocabulary. Some vocabularies have inverted headings and nasty little conventions that just are not natural language. A lot of those can be processed algorithmically, and we have little routines that will look for that kind of thing and convert them into natural expressions. But there is a lot that can be mined from any standard taxonomy. Granular subject-specific taxonomies are going to tend to be much more readily usable than the categorical ones. Kind of goes without saying, but I'm saying it because where you do have these broad categorization taxonomies, simply by OWL same-asing them to concepts in the linked open data cloud, we can mine the missing pieces in a lot of cases to pull back machine indexing rules. Not that those rules don't need validating, not that those rules don't need some human curation, they do, but it's a great way to jumpstart a project. And the fifth bullet there is the interactions. Every interaction that then happens should feed back into the knowledge base, into the learning base, so that we can retroactively go back and look at the sentences that worked and the sentences that didn't work, and mine extra language and rules out of that. That's my talk, 19 minutes, so okay. Thank you.